Hello and welcome to our next workflow demonstration. Today we got this plastic cap with thread and it's completely broken as we see. Well, okay, not completely, it's still sort of holds its shape more or less, but essentially we have to replace this part and we need to do reverse engineering of this scan data. So in general, if I'm looking at this part and considering how to plan my workflow, most likely I will try to do this based on two solids. So first I will work on this thread part and all the extrusions related to this, and the second part will be the decorative cap itself. And of course, as a first steps in our reverse engineering tasks, we need to align this scan data to coordinate system for easier workflow, because we can see that we have quite a lot of patterned features all around this. So it would make a lot of sense to align this to coordinate system to use like circular patterns and things like that. And in order to do that, of course, I'm going to extract a couple primitives first. So let's say I want to use this cylinder as a primary feature. Okay, you can see cylinder doesn't fit here too well. Let's try to switch this to cone. Cone fits, I think, slightly better. Well, in general, probably there is like super tiny draft angle. So if I'm looking from top side, I can see that here is draft angle. That means this is a cone, not cylinder. And let's hit create as a secondary feature for alignment. I think I will create plane here. Okay, so here I can see that this actually might be not on the same level as these two big cutouts, so I'm going to use, well, actually I can select all of them and see how it goes. So something like this, and let's say I want to see here plane analysis. Okay, looks good. So let's create this one, and as a third feature, probably I could use this straight line here to define direction. So let's fit one entity there by creating cross-section sketch and fitting line here. Okay, so we have done this, and let's align this by coordinate system. So typically we're trying to use plane as a first feature for alignment, but in this case I'm not completely sure this plane is perpendicular to cylinder, considering this part is broken, so probably they are slightly out of alignment. So as a first feature, I'm going to use cylinder, then plane, and only then this line that will define direction. So we can see this preview of coordinate system, and I want just to flip it. So I have z-axis in correct direction. So let's hit apply and see how it looks like from isometric perspective. And yes, this is what I wanted. Okay, so now I can close. I don't need this sketch anymore, and I don't need plane. So as my next step would be not to jump completely into reverse engineering task, but I want to create cross section for evolve and essentially later to make revolve to verify how good this part actually fits the coordinate system, if I have aligned this correctly or not. So on this side I can see I have this crack here and some slight misalignment of surfaces, so I want to try to use a different zone of this part where I have less deviation between surfaces, and probably I could use it here. Just set this to exactly 90 degrees and hit create. So as a next step, I think I will put one line here. Then I would like to fit one more entity around here. Let's say probably an arc over here. Let's try to intersect them. Probably I will add fillet here some slightly later. One more line here. Let's intersect them. Let's add fillet. Let's just extend this side. Currently, I'm not going to try to make it super close, but well, in fact, we are already super close. So the deviation analysis for entities are set for 0.05 millimeters, and it shows green, so we're within this tolerance right here. Of course, later I can come over back and see, probably refine my sketch to get closer. So what do we see here? We see that actually currently I'm pretty close, and as I said here, my construction entities, so this region is fine, and I chose this side because I had less deviation between these broken surfaces here, and currently it looks very well. So means my alignment is good enough and I can proceed with my reverse engineering tasks here. As I mentioned previously, I'm going to build this part in two pieces from two solids. And the first part I'm going to work on will be the central part, extrusion with thread. And the second part will be the cap itself. So in order to do that, I think this time I will just start with creating helix here. So I have to find some nice geometry where to work on. Or actually, before I'm doing that, I will create another test surface, revolve, to see if these threads are actually intact all around the part. So to do that, I'm just going to fit another line. I can see that all threads are matching my line here. Let's do revolve, solid. Okay, so here we can see it's good. This one is slightly worse, so I assume there is some deviation because of the warping, or considering that 3 or 4 features of the central part are off deviation, I actually shouldn't use this one. So let's get rid of this one. Let's get rid of sketch and let's create another sketch for evolve based on other side. Let's go to this one. Let's create another sketch here. And absolutely the same way I'm fitting another entity here. Let's revolve it. And let's compare. So we're good here, we're good here, we're slightly off on this one, and we are half good here. So this means basically these two features are slightly twisted, and we can actually see here we have the biggest deviation between two surfaces. So this might make sense actually. Okay, so now I can close it. I won't need this anymore. I can delete this and I will just keep my sketch open for reference so I can see where to which region of this part I'm going to focus on during reverse engineering task of these threads. And now I can go to create a helix here. And first what I need to select axis, and this is going to be my z-axis. And before defining start and end point of this thread, I'm just going to roughly measure pitch first, so the helix doesn't create me some crazy amount of revolutions here, but it will be already close to my actual needs. So let's pick start point and let's pick end point on this side. Okay, so as we can see, our helix is close enough. Probably we want to adjust pitch to, like, let's say 1.4. Okay, like this, so it pulls slightly down on this side, but we're quite good on the bottom side. Again, this is something we have to decide to stick to some logical dimensions or keep it as we have our scan data. So for now I will keep this at actually I will go to 1.4 and later if there is something I can just come back and change some settings. And I will need to extend this helix natural in one direction and the same natural on top side. Okay, so we have defined our helix here. As a next step, I think I want to verify my helix, so I'm going to construct plane along path, select this helix. I'll rotate it somewhere, close to previous sketch I created. Create it here, and let's create thread profiles here. So simply fitting entities, then intersecting. On this side, I'm just going to extend it slightly. So this is quite important thing here, not to make self-intersecting surface, because if we will create self-intersecting surface, we will have problems down the road, and this is a very well-known issue of the parasolid kernel. So it cannot handle self-intersecting surfaces, and this will be a big problem if you will create self-intersection here, because parasolid kernel won't be able to create good quality solid, and most likely you will end up with some errors. Okay, so once I have created profile, you can go to surfacing, choose sweep, select this profile, select helix as my path, and let's enable analysis. So here we can verify how good fitment of helix in comparison to scan data thread. And I can see it fits actually very well, and I'm going just to accept this. Okay, now for now I can hide this swept surface, and I want actually to get back to this sketch and create the first solid of this central feature here. I'm going to recreate this as a complete profile on this side. Let's fit all the entities we need here. I'll set this to be vertical. This doesn't look, that should be horizontal completely, so probably again some draft angles and things like that. So top side, and say some average here like this. It's a good question if I need here another vertical line, but we can fit it actually. So let's make one like this. Probably I want to fit a couple entities here as well to make this slight indent there. And let's just extend this to our axis, the close profile. Extending this side as well, slightly inside of cap. And let's also close it here. Now we can do a revolve. And we have our first solid feature. But at the same moment I can see that actually this is slightly faulty, because here we have just some straight cutout. And that means I want to modify my sketch slightly. Okay, not this one, but sketch 3. So let's just change slightly this profile for my sketch, and I think actually I will just get rid of these two entities and intersect these two like this. Okay, and see my revolved solid. Let's run comparison, and okay, we're good to go. So once I have done this, I can take a look if my sweep is extended completely enough to cut all this part. But I can see, okay, on the bottom it's nearly there. And on top I need to extend it quite a little more. So I can go to edit my helix right now, and I want to extend end, which is top part for me, and I will set this to like 200%. Okay. Okay, good. So I can see it's completely intersecting, and I want to do the same on the bottom side. I need just a little bit of extension. Let's say 150%. Okay, look good. So I can hide my helix sketch for now, bring back my sweep, and actually do the trim for this part. So I don't need this as long as I don't need these. So this way I end up with solid threaded one. should fit absolutely nice. So we can verify this once again. Okay, so we're pretty much good everywhere. And we're under 0.1 millimeter deviation, so it's perfect. Okay, let's close this for now. And what now? At this point, actually, I can add here a couple of fillets, but I have to be slightly careful here not to add too much because, well, you know, the scan data is typically rounding off all sharp corners. And okay, we can see that 0.5 is like way too much. Let's try with 0.1. We're good on the deviation, but of course we have to consider, isn't that too much? And this is completely up to you when you're doing these reverse engineering tasks and you have seen the part itself. So we need to find some balance between logic and what we see in deviation analysis by considering factors that are affected by 3D scanning itself. So, okay, I'm just going to keep this at 0.1 millimeters, click accept, and I will add fillets on these two edges as well, and probably I will go with the same 0.1 and hopefully this will work. Okay, so this failed to fillet my part, and so this means it's slightly too much, and we can try to go with 0.05 maybe. And in this case it still doesn't really want to work, probably. Okay, so this might be probably due to these sharp corners. So we can try to do this by using one side at a time. Let's say what would be the result at this moment. Okay, so in this case we have some result. And well, okay, this doesn't look like completely enough, so let's try to move it to 0.1. Okay, and probably we might need slightly more. Let's try 0.2. Okay, so 0.2 looks like something pretty much close. Okay, let's click create and stay and try to, well, let's try to fill it on the other edge. Okay, perfect. So this worked out for us. Now I can accept all this and consider this thread to be done. So what I need now, essentially I need to cut this part. Probably not cut part would be a good explanation here, but I have to create these cutouts from this solid. And in order to do that, I have this cone that I previously fitted to scan data for aligning purposes, like this. So actually I'm going to edit this and say I don't need this to be a solid but a surface. Okay, so I have one feature. As next feature, I would have to create, I think, these vertical walls. Let's see. I have pretty good scan quality on this side. So I'm just fitting two entities, extending them like this. Of course, we can always try to make this like in logical order. And let's say I want to create this at an angle of 45 degrees. And after that, for example, I have fitted one of these entities, and let's turn this into a construction line, select both of them and mirror and see how good it fits. But yes, again, this is first of all plastic part, secondary it's broken, and again we have to find some logical way how to create this. So if we want to create this as a perfect CAD, probably this would be a correct approach, but at this moment we have to understand that we will see more deviation at the end. So this is something to consider. Okay, so once I have created these two profiles, I can extend extrusion height to intersect completely my solid. Okay, like this. So for now, I'm just going to do a circular pattern, these last extruded surfaces like this. And what I need now, actually now I need another cylinder or cone. In order to do that, I'm going to create another cross section for revolve. Move it slightly, something like this. Actually, before doing that, again, I want to make visible sketch that indicates which one of these four features I used for as my nominal one. And essentially, I want to create this cross section based on this feature. Okay, so now I can see this inside profile is slightly curved. And let's try to fit it properly. Okay, on this side we're good. So let's fit another line here. Intersect, extend this side slightly. Let's add some radius here as well. Okay, like this, and now I can do revolve. And let's verify. Yep, looks good. Okay, so for now I'm going to hide this sketch, unhide my circular pattern, and unhide my cone. So from this, I'm just going to trim all this together to get just one part of all of this. So I don't need all of these. Probably it might be smarter to go one by one. So maybe this way. Okay, I need only one feature here. Something like this. Okay, so I can unhide my solid and I can see I'm going to use all this to trim apart this part. Okay, for now I could just do another circular pattern, but at this moment I realized that I slightly messed up here, so I can actually undo this trim and edit this one, reset it, and So I don't need this, 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 this. Whoops. This one, this one, this one, this one, this, and this one surface. So let's accept this and let's redo another trim here. The way I end up with 4 individual surfaces. Okay, like this. Okay, and now I can actually trim this part. So we don't need this one, this, this, this. And repeat the same on the bottom side. Of course, at some point, probably I could have created this different way to have just a solid so I can trim them much quicker. But well, as I started this way, I'm just going to keep it this way and will spend slightly more time than I would normally do. Okay, so we have cut out middle part of all this, and now I need to do these 4 large cutouts. In order to do that, I'm going to create horizontal cross section here. Okay, and let's unhide my sketch 3. So I know I was working on this side here. And again, I'm coming here to fit straight line like this. I'll just create another construction line. Let's say this construction line is at 45 degrees to my vertical line. Then I'm going to select this entity, my construction line. I say I want to mirror this. Then extrude. Intersect it completely. You can actually unhide my solid right now to make sure my surfaces are intersecting completely. Okay, at this point I just go to CAD tab, do a circular pattern for this. Okay, then let's hide this sketch and let's trim this part again. So from here I don't need this part, this one, this, and this one. And I need to remove these faces. And now I can accept this. Okay, so now I can hide my scan data. Let's see how it looks everywhere. Okay, so we're good, 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 good. Mostly we're great. And last thing, I need this straight cutout here. So let's create one. Probably I guess I will have to I think I will just create a horizontal extrusion, or maybe not. Okay, so let's try to see if this is actually a planar surface here. Okay, we see this is pretty much a planar surface, so this makes our life much easier. Now I don't need this plane, so let's create another cross section. Let's pull this up to somewhere where we have good enough scan data to fit nice and clean entities. Okay, so tries to fit still circle here. So what I'm going to do now, I will just create a circular pattern, accept this and click auto join them like this, but I don't need to cut this inside cube out here. So I'm just going to select all of this, say I want to offset this, whatever, something, and extrude this. Let's enable analysis. And I'm going to snap to mesh. Bottom side, the top side I don't really care, and at this moment I cannot hide my previous solid, and say I want to cut this like this. Okay, and we can take a look how it fits. It looks good, the top side, and from now we can take a look how logical all of this is. Okay, so here we can see we have more sharp this edge here than initially, but that's a good question what to do here. Probably we can create another revolve to have this cutting surface at slight angle. If we need to, but on this side we are very well, on this side very good as well. So probably I might just ignore this fact or add just a fillet on top of this, not to have so sharp angle here. Okay, so something like 0.2 looks good. And probably I would need to create the same fillet on this edge as well, but here it might be a problem. Okay, no, it's not a problem. It works absolutely great, and let's just pull it down till we see green, and this is close to the same 0.2, and let's apply fillet of 0.2. Okay, so we're good here. On this side we have already like a normal thread profile, and I will assume this part to be finished here. Okay, so what I need now I have to recreate this cap surface, and I have two options to create this straight away as a solid or just create a surface and then try to thicken it. So you can try both ways, but considering I have good enough geometry, I would just go and recreate this as a solid as a first. The next step for me here would be to create cross sections for revolve of main cap, and I remember that I have created revolve that I was using for verifying how good my fitment is, and this revolve used sketch 2, so I'm just going to duplicate the sketch and edit this because I already have created the proper sketch for this, and just get rid of this inner cone. And from here I'm going to select all these entities and say I want to offset them, flip it, okay, so this, as we can see, doesn't actually match perfectly, so I'm just going to create a inner profile from scratch. And in order to do that, so this zone looks like more or less flat to me. Let's fit one straight line here. Actually, this part looks kind of flat, but seems not completely, so let's fit an arc here, intersect these two. Here I can see, oh no, actually this one is not a completely vertical line, normally for all the part. And this means actually this sketch is not the greatest that I could use. So I'm just going to get rid of these entities here and create this as a just a surface. So let's create revolved surface. Okay, let's hide this one. And now I need to create another cross section for revolve. Somewhere where I have clean profile. And probably I can just go to this side. And create one here. On the other side, I don't have good enough information about surface in this area, so let's just pull it back somewhere here. This looks good enough. Let's enable clipping, and from here I can start to fit my entities again. Probably like this. Let's try to intersect these two and add fillet here. Fold this slightly so I can see some tiny deviation on this side, but this is under 0.05 millimeters, so I'm just going to keep this as it is. And I'm going to fit another straight line here, intersect them. Let's extend this one, add fillet. Let's say this is like 2 millimeters. And let's extend this one up to axis. And let's create a revolve. Okay, so at this point we can take a look how it fits. So we're good all across this region here. And we have some slight deviation where this part is broken, and we have the biggest misfit of surfaces on this side as well. Okay, so we're good on this. We have the inner and outer surfaces made, and at this point I need to cap them to make solid. Or optionally at this point, maybe first I want to fit this vertical feature here. So in order to do that, let's create another cross-section sketch and let's fit just a straight line here, extend it slightly like this. So I can say this is horizontal because I use this entity to align my scan data to coordinate system, and I know this is just exactly along the axis. So let's extrude this one. So it intersects my revolve completely, and from this point I understand that I should extend the sketch slightly. So let's just drag it longer. Okay, like this. And now I want to trim, get rid of that and get rid of the surface. Okay, like this. Okay, I'm good on this side. And the outside is perfect as well. Now I need to extract some plane to trim all these surfaces and get this part to a solid state. So currently I can see it fits very well, but I want to make this perpendicular to or parallel to XY plane. So at this point we can see that there's some slight deviation appeared. And again, this deviation, as we can see, is inside where we have the biggest difference between broken surfaces. So let's create this plane and hide my two surfaces, select all of this, let's trim it, and probably we can try quick solid. Okay, so it almost did the job. Basically, quick solid will try to create the maximum volume solid based on surfaces you got here. Okay, so we have the solid body and we have our thread part. But before I am combining all this into one, I still want to create all these small cutouts here. In order to do that, I'm just going to create another cross section to get proper profiles of these cutouts. So it's something, say, like this. And let's see what we can actually do here. So let's select these slice points and these ones to fit entities. Let's extend them longer. Actually, probably I don't need this one, but I want to use this one just to create a sort of cutting tool. Like this. So at this point I can actually try to I will just close off these profiles first. So I have closed sketch. And now I actually can try to do a circular pattern for this part and see if it's going to work all around it. So here we can actually see that it's slightly different. It's not matching completely well. And this means I will have to probably fit more entities or just probably I will accept this for now. Let's get rid of these entities here and all this part that doesn't fit well. So here we can see green, 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 not so green anymore. So probably I want to get rid of these all as well. And here we have this larger cutout, so let's create this as a one big profile. So from here I would have to deal again with creating more manual profiles and fit entities. Yeah, sadly this didn't work with patterning, but it is as it is. Not always everything is that super perfect in our life. So from here again, I would have to repeat fitting entities. Of course, probably this deviation that we can see here was simply due to damage of this part. And maybe a logical way would be just to pattern it and don't care about the actual deviation of these cutouts, but well, in some cases that might be wrong, in some cases that might be right, but I think I will just create manually these entities here and we'll call it that a day. Okay, so on this side it's slightly more complicated. So this looks like slightly wrong for me. So let's reposition this entity like that. Okay, so this cutout I think I will leave for later. I will create this as a separate feature. Meanwhile, let's get done with all these that we have good information at. Like this. And here again manually. Okay, so let's just make them as a closed profile. One side, on another side. A little bit of trimming. Not the quickest way how to solve this task, but messed up slightly. Let's get back. I don't need this one. Okay, like this, and let's repeat the same on the other side. Okay, like this. So we have these complete profiles. Now I can do an extrude. Let's see, I want to focus on this side. So I'm going to snap here. So at this point I can unhide my cap solid and say cut. Okay. Okay, so this looks good. And now I need to recreate this last cutout here. In order to do that, I'm going to create another cross section. Okay, so something like this. Let's fit here. Straight line. Let's fit here another one. Extend all of these. Like that. So this looks like, well, I would have to create this from several features, but actually I want to try one trick and see if that is going to work. So I will create now, this is just a one profile. Extrude it up to here. Oh, actually I will extrude this up to the same height as I created previously, all my cutouts. Say cut this, okay, like that. And from here, I want to create another sketch. Approximately like this, because I want to capture this line here. Let's extend this, okay. And now I'm going to select this face and this sketch and say project sketch. Okay, so as you can see, this created me basically not created, but by divided this face into two separate faces. And now I can actually go to move face command, probably with offset. And let's just try to move it slightly, like 0.2 millimeters. Okay, good. So, well, this worked out actually. Okay, so perfect. We're quite close everywhere, and I just have a couple more steps to do on this part. So let's hide my cap solid, and what I need now, actually now I need to create all these bores here. Let's try to understand if they are completely vertical cutouts or not really. Well, it seems that they might be vertical, but so let's give it a shot. What I need now, I want to outline this mesh. Okay, let's create this. So what can I see from here? I have like pattern features. Again, 4 circular patterns of these cutouts. So in order to accomplish this, let's try to fit circle. Actually, extrude the first one to see how good it fits. Okay, looks like it fit very well. So I can go to edit my sketch. Fit all the rest. Okay, so here it's slightly more complicated. Okay, so first of all it's broken, and secondary there is some, looks like parting line from a mold. So in this case I have to consider, probably I should have worked on this side, because here I don't have too much of misplaced surfaces, and so yeah, let's come over here. Let's select here some points. Say I want to see circle here. Let's do the same on this side. Maybe something like this. Okay. This is from perspective of like super clean CAD models. We should figure out how to pattern this. So basically I can fit these two, then try to mirror them to the other side. Actually, why not? We can try to do that. And for example, I can create the vertical line. Okay, so I can see this one clearly isn't on my vertical line, so probably it's not that great aligned to this cutout. Of course, I can try to mirror this one and see. Okay, so it's quite off actually here. What I could do in this case, probably I can position this center line, this circle, center point, and try to mirror them right now. But well, again, it's quite far away. So let's just skip this plan and fit primitives based on our scan data. Okay. And now let's fit this last one here. Okay, back. So at this point, I would like to make all of them equal diameter. So probably I'll want to set this diameter to something like 0.7 maybe. Well, let's say this is 0.8. So we can see we're getting a little bit further away, but As I figured out previously, this was our parting line for draft. Oh, actually, I will go back to 0.7 to have some average. So let's just extrude all of this. Okay, we can verify fitment. It looks good. And let's just create CAD circular pattern for instances, except, and of course, as we can see here by patterning again, it's getting slightly moved away somewhere. Well, first of all, this is plastic part, and we can never know how perfect was it. And I will assume I want to create this as a more or less perfect cut part, so I'm just going to use this pattern here. And this time I will use this option count cut from selected solid and selecting my pattern features and cutting them away. Okay, so we're here right now, and let's see what else do we have left. So okay, actually here we still need to create cutout and central cone. In order to do that, another cross-section sketch for evolution. Let's quickly fit here a couple entities on this side. So we have a couple options. So let's get it snapped, make it horizontal, let's intersect them, let's add radius. Oh, here we can see it's not that perfect, so means this part isn't like a complete dome on this side, and there to work this out, I will just create a tangent arc here, and I will snap it onto axis. Okay, so probably on this side we can try to move it slightly to get like average. And let's just close this profile so we get this as a solid part like this, and at the same moment we can do cut operation instantly. Okay, so let's see. Okay, this looks good. So more or less this was one of last actions here, and at this point I can just combine these two solids together and get this part as a one single solid. So it's something like this. Let's see what deviation analysis shows us. Okay, so I haven't recreated these small indents here. I'm not sure if that's necessary, but of course it's possible to recreate them, but to save your time spending on watching these tutorials, probably I will just skip them because it's not super important geometry on that side. And of course, if anybody wants to do that, you can recreate them if there is need for that. Otherwise, I hope you found something useful in this workflow demonstration, and see you in the next one.